All right, hey kiddos. Today we're going to talk about geometric sequences and series. Remember, sequences is just a pattern of numbers separated by commas, and series is a sum of a sequence. So basically, instead of separated by commas, it's separated by, addition or alternating between addition and subtraction. But anyway, so remember, geometric sequence is when you are multiplying by some constant number each time. The general form is u sub n is equal to the first term, u sub 1, times r to the n minus 1, where r is this number that the number that you're multiplying by, the common ratio. Then we have this formula, which is the sum of the first n terms. So a finite sum, that is the first term times 1 minus r to the n over 1 minus r. And then we have one additional formula this time, where we can take the infinite sum of a series. That's the first term divided by 1 minus r. Now this can only be done when the absolute value of r is less than 1. We've talked about why that's true in the past, so I'm not going to spend a long time doing it, but it's common sense. If you're multiplying like on this one or this one by something, multiplying by 4 each time, if you were to take the sum of all infinite terms, obviously that's going to go to infinity. You're not going to be able to find a finite answer. But something like, hold on, sorry. Something like 24, 12, 6, 3, 1.5. If you were to add these together, you'd get 36, then 42, then 45, then 46.5, then 47.25. Like the sum isn't going to infinity, it's approaching some limit, and the infinite sum is that limit. Okay, so let's just walk through a few of these problems. Again, just like last time, you know this stuff for the most part. I just want you to get it back in your brain. So let's just do these problems. So the first two is just finding a term in the sequence, so I'll do it quickly. So 7th term, we want u sub 7. Oh, sorry. So u sub 7 is equal to the first term, which on this one is 1, times r, 4 to the 7 minus 1, which is just 4 to the 6th, or 2 to the 12th, which I believe is 4,096. Let me just double check. 2 to the 12th. Yeah, okay. So, next one. Sorry. Next one, we want the 8th term. So that's u sub 1 times our common ratio, which this time is negative 2, to the 8 minus 1. So negative 2 to the 7th times 7 is negative 896. And this next one is a little bit different. So we have a geometric sequence, 5, 15, 45. We want to find the first value of n such that the nth term is greater than 50,000. So we need an expression for the nth term, which is first term times r, which in this is 3, to the n minus 1. And we want this to be greater than 50,000. So what I would do is to type this into y equals, and then not use the graph, but in fact use the table. The table is going to be really nice because we're really only dealing with whole number values because n is term number. And you just look, find the first time it's greater than 50,000, you scroll, and you get n equals 10. Pretty straightforward. Okay, so I'm going to skip that for now. Let's talk about sum problems. So let's just do this first one. I don't need to do the second one. So I want the sum of the first 8 terms. So, lost the pen. Sum of the first 8 terms not infinity, 8 terms, is the first term times 1 minus r, which is this, in this case is 3, to the 8th, all over 1 minus r. So now we just do all that basic algebra. So 1 minus 3 to the 8th divided by negative 2 equals 3,280. Pretty straightforward. So I want to do just these two other problems, and then we'll call it a day. Because like I said, you already know this. This is just getting back in your brain. Yeah. So let's start with this one. Let's just do the infinite sum. Now, if you notice on this one, r is 1/3 on this problem, because you're multiplying by 1/3 as you go along, which in fact is less than 1. So we can find the infinite sum. So infinite sum is u1 over 1 minus r. So on this problem, that's 18 over 1 minus a third, which is 18 over 2/3, which is 27. And that's your final answer. Easy enough. Okay, this problem, we're given our first term, we're given our common ratio, we want to find n such that the sum of the first n terms is 26,214. So we set up our sum of n terms, so u1 times 1 minus r to the n. Whoops. That was pretty bad. It really doesn't want me to write this in. I got a janky stylus situation going on here. Why won't you let me do it? Okay, forgive me. There we go. Over 1 minus r. That's just the sum of the first n terms. And we want this to be equal to 26,214. So that's just going to be some algebra. So this denominator is just -1, so multiply that to the other side and then divide by this 0.4. So 26,214 divided by 0.4. That gives us our next algebraic statement of 1 minus 2 to the n is equal to -65,535. It's negative because this denominator was -1, and I just multiplied it over here. So next step is to subtract 1 and then divide by -1. So we're going to get, oh my gosh, we're really struggling on the last problem. 2 to the n is equal to positive 65,536. Now, to solve for n, we just need to take the log 2 of both sides. So n is equal to log 2 of 65,536, which I believe is 16, if I remember. Yep, it's 16. Okay, so we have done a few basic general term questions using the table. We've remembered all three formulas, and then we did the various sum formulas. Pretty straightforward. You've learned it last year. Yeah, I have a feeling this isn't going to be an issue. Starting soon, we're going to add on to some things you haven't seen before. So thank you for your patience. Hope you all have a good day. See you later.